Now, I'm going to do a giveaway. Look over in the Facebook group. Let me load up the group real quick. But if you go to the pinned post right up here at the top, or you can just scroll down a little bit, look for that link right there. Link for tonight's giveaway or giveaways. I'm going to give away a few copies of my brand new med dosage workbook. Some people have peer reviewed it for me, typos. My grammar's not the best, but we fixed those, and I think it's ready to rock and roll. So I'm going to drag that over here. And if you've used my T's Math workbook before, then you know how to navigate this thing. So this is the med dosage workbook. Right now, if I just, and by the way, if you're new to this, you can tap on this blue link right here. And this is the table of contents. And the best way to utilize this is on an electronic device. Any electronic device, because you can actually tap within here. And live session 1, live session 2, live session 3, I did some of the basic conversions, and we even did some weight-based conversions. And we also did some of these down here. Let me zoom in. So section 4 in the workbook, milliliters per hour, GTTs per minute, heparin, very common things you run across in med dosage. And then section 5, this is where from time to time when I'm tutoring students, this is what led me to make this workbook. I tutor a lot of students both for the T's and then they pass the T's test and they take med dosage. I teach dimensional analysis. I don't teach a formula approach. I don't teach how to know when to multiply versus knowing when to divide. But these are challenging. So there's going to be some distractor problems. And for example, if I just click on any one of these, for example, let me go back to weight-based calculations. That will automatically jump to that section in the workbook. And every section has a combination of problems without drug labels. For example, these right here, all of these are weight-based calculations. But then there's going to be some problems in the workbook that also have a drug label. And you'll have to read that drug label. And something else you'll probably notice too is the way the problems are worded, because I have worked with students all over the country. And for example, like number 5 right here is more of a sentence structure to this word problem, whereas some med dosage courses, they just write out order. They might put the patient's weight if it's needed, and then they'll say what's available. And for this particular example, that's where we're going to use that drug label. So there's various ways that we can see a med dosage problem given to us, and the workbook covers all of these various ways. Now, if I jump back up at the top, we're going to do some math right here in a second. What's also included, common abbreviations, and then the common conversions. Sometimes less is more, sometimes less is better. And when it comes to med dosage and dimensional analysis, this is what you need to memorize. You don't have to memorize any formulas. You need to memorize your conversions, and that's it. Once you get the hang of dimensional analysis, I'm telling you, people who I've worked with one-on-one, nobody has ever said they hate dimensional analysis. But please, if you haven't, check out live session 1, 2, and 3. So this is going to be what's given away tonight. There will be updates just like the T's Math workbook, and then the solutions are included as well. So if I jump to the weight-based calculations, not only will you have just the answer, but you're going to have an explanation of how to do it. I'm going to show the dimensional analysis. All of these solutions are not just answers. There's going to be an explanation on how you do it. But yeah, that's an overview of the workbook. Real easy to navigate on any computer or iPad or tablet or anything like that. Anyway, here we go. So tonight's session, tough problems, challenging problems, creating the double slash. And what is the double slash? Double slash can be milligrams per kilogram per day. It could be micrograms per kilogram per hour. Double slash. Now, I've mentioned this in earlier live sessions, but I'm going to go ahead and put a problem up here, and I'm going to make this interactive for you all. So, if you've never done a live session with me, I have a timer up here. So I'm going to pop this first problem up here. I'm going to shut up for a little while, and let's go ahead and get started. I'm going to put a timer, and I'll be back momentarily. All right, so here we go. Again, I'm going to say this multiple times tonight. I have a tendency to repeat myself. I think it's a good teaching quality to have. But y'all, if you're just getting started with dimensional analysis, you need to check out live sessions 1, 2, and 3. Then maybe come back and revisit this. Now, this falls, like I said, y'all, this falls in that challenging problem section of the workbook. And we're going to be focusing on this section because really my live sessions have covered a lot of this other stuff that you see here in the table of contents. So anyway, here we go. We have our med dosage problem, and in the past, the way I teach this is I say, what are you trying to find? What we are trying to find is we're trying to find how many milligrams per kilogram per day is this 84 kilogram patient going to receive. And I call this the double slash, and what we have to do is we have to build this. That's why I call creating the double slash, building the double slash, milligrams slash kilograms slash day. Now y'all, in my previous live sessions, a way that I've told you could always write this is you can put mg up top and you can actually put the kg and the day at the bottom. This is our goal. Whatever the question's asking you, and this is what I've said over and over and over, whatever the question's asking you to find, in previous videos it's been how many milliliters, or how many milliliters per hour, or how many GTTs per minute. Whatever the question's asking you, this is how you start things off. I'm going to take this top word and I'm going to look back in my problem, milligrams. Is milligrams mentioned anywhere in this problem? And if it's not, you have to use a conversion to bring it in. But in this particular example, the milligrams is mentioned right here. So this is a great starting point, 750 milligrams. I'm going to start off my dimensional analysis with that word. 750 milligrams. The reason why I'm doing that is because we're already setting ourselves up for success. We already have the milligrams at the top. Now from here, we want to focus on getting rid of some words and bringing in some other numbers. So let's see. What do we know about this 750 milligrams? This 750 milligrams is to be given to a patient every 12 hours. So we can say 750 milligrams at the top, and we can put this over 12 hours at the bottom. I'm not going to skip any steps here, y'all. I know some of y'all probably can. Some of y'all may just know that that's going to be, 2 times per day. I'm not going to skip any steps. After working with so many students, I see people get mixed up about multiplying and dividing all the time. So, milligrams is good, but we have a lot more work to do in this problem. We got milligrams at the top. We need to get kilogram and day at the bottom. Well, watch what I'm going to do here, y'all. I can go ahead and work on getting this day to pop up at the bottom using dimensional analysis. Let's use a conversion. Isn't it true that there are 24 hours in one day? Literally, this is a conversion. It's not your typical milliliters to liters or milligrams to grams, but it's still a conversion. Now, why did I set it up like this? One reason, we can cancel out hours. That's the big idea of dimensional analysis. Canceling out words. If you have a word at the bottom and a word at the top, you can cancel those suckers out. Now, the second reason I use this conversion, check out what we've done. We have accomplished some more of our dimensional analysis. We have day at the bottom. But we still have a little bit more work to do, y'all. We have milligrams at the top, but we need kilogram and day at the bottom. And right now, all we have is day at the bottom. Well, what do we know about kilograms? The patient, luckily we don't have to do a conversion here, but we may in a minute. We know the patient's weight. Now, in the past, when we've talked about patient's weight, In the past, we've done very often, we would do we would do 84 kg over 1. And if I'm not mistaken, in my previous sessions, I've even mentioned too, what this 1 really stands for is the 1 patient. But I don't want to set up my fraction like this. I want to flip it. So I'm going to put the understood 1 patient at the top, and I'm going to put my 84 kilograms at the bottom. Why am I doing this? Why am I doing this? Well, look, we got milligrams up top. We got day at the bottom, but by us putting the patient's weight in kilograms at the bottom, there is that other word that we need. And I call this building the double slash. That's literally what we're doing. We're building up to get all of these words. And once you have those words, we are now ready to multiply and divide, just as I've discussed in all of the live sessions up to this point. So that's a real fast calculation. If you're not familiar with this, trust me, you go back and look, it's the same way every time. Multiply all of your top numbers. You can ignore anytime you see a 1. So my top numbers, 750 times 24. And you can go ahead and press enter if you want to, but I'm not going to waste my time and write that down. Immediately, I'm going to start dividing by my bottom numbers. And just like up here, we didn't have to mess with the 1. We don't have to mess with the 1 down here either, y'all. Just divide by 12, and you can also divide by 84. And all in one swoop, divide 12, divide 84, boom. So if we round this to the nearest tenth, and I'm seeing some answers come in, this will be 17.9. Let's look at our words. And let me slide this over just a hair. So this will be 17.9 milligrams per kilogram per day. And notice we've built that. We got our milligrams. And again, y'all, it's totally fine to have these 2 words together at the bottom. Now, there will be some times, I don't think I have these tonight. I don't have examples tonight, but there will be times that this fraction may need to be flipped. That's another section in the workbook that talks about infusion time. But for now, rounding to the nearest tenth, it would be 17.9. So we're building the double slash. Now I have another example for you all. I was about to ask, are there any questions? Because I'm so used to doing this on Google Meet with 10 students. And I do kind of like offer a point in those mini sessions, only 10 students for questions. Feel free to type questions over in the comments. I'll try to address those. And by the way, if you're just joining in, this will all be saved. You'll get everything that you see right here. All of this junk, you'll get it when we're done tonight. So I'm going to go ahead and pop up number 2, and I'm going to give you 2 minutes and 30 seconds yet again. This is a very similar example. I'm going to go ahead and get the ball rolling. You want to build milligrams per kilogram per minute. So did I say milligrams? It's micrograms per kilogram per minute. This is what makes it a little bit tougher. 2.5 minutes. Give it a shot. All right, so here we go. We're trying to build a double slash again. And when people are doing med dosage problems, a lot of times they say, how do I start? Or where do I start? So let's have a look at this one. We're trying to figure out micrograms per kilogram per minute. Now, y'all, every single one of these is going to require a conversion. Micrograms, it's not mentioned, but milligrams is. Kilograms, we're going to have to use a conversion because we have pounds. And y'all, I'm not going to skip steps. I'm going to let dimensional analysis do all of it. This takes away all the guesswork. All the guesswork of, should I multiply by something? Should I divide by something? Folks, you practice it. I promise it takes away all the guesswork. And then this third word, we're going to need a conversion there too for minutes. So our goal, what are we trying to find? Micrograms. And then the double slash kg/minute. Just take my word for it. This will always work. We can stick those both at the bottom. This is what we want to build. So right off the bat, I want to do something that talks about micrograms. And by the way, let me just establish this. This is our goal. Always start with that top word. So let's see micrograms. Now, y'all, I like to teach it the same way every single time. Whatever word is at the top of my first fraction, that's the word I want to start off with. And notice we don't have that. Micrograms is not mentioned, so I'm going to use a conversion right off the bat. And you want to have this one memorized. 1,000 micrograms is 1 milligram. This is always true. Just like there's always 60 seconds in a minute, there's 1,000 micrograms always in a milligram. Why did I do this? 2 reasons. 1, we wanted micrograms at the top. And 2, the reason why I use this conversion is now we can tie in the 120 milligrams. Notice I'm putting that at the top. Dimensional analysis, all about getting rid of those words. And this 120 milligrams is in 750 mLs. And y'all, I mean, if you're just getting started again, this is going to look crazy, but the flow is so nice for this problem. Watch what happens here. So we've gotten rid of milligrams. Now we got to get rid of these milliliters. Well, I like this because it's got milliliters in the problem and it's bringing in the time. Even though it's not minutes, daggone it, we got some type of time popping up. So I'm going to put the 60 mLs at the top, and this is 60 milliliters per hour. Cross out our milliliters. Since I'm on a roll here, I see that time has been introduced into the problem. Let's go ahead and knock out one of our pieces that we need to build. We need to build minutes at the bottom. So what I'm going to do is I'm going to do a quick conversion. There is 1 hour. That's the same thing as 60 minutes. And look at what we're doing, y'all. Getting rid of the hours. Look at what we have. We have built another piece to our double slash. We have it exactly where we want it. And now all we have left to do is just like in the first problem. You can do this in any order, but this is the way that I do it. I need to build in, or I need to put in kilograms. So take note, kilograms needs to be at the bottom. And we also need, or what I'm going to do, I'm not going to skip any steps. I'm going to do a conversion because the patient's weight is in pounds. Now, I want that kilogram at the bottom. So I'm going to put 1 kg at the bottom. And that is the same thing as 2.2 pounds. Now, I'm not getting rid of a word right now, y'all. I'm not getting rid of a word because I don't want to get rid of minutes. I want to leave that there. What I'm doing is I'm putting that word kilogram at the bottom where it needs to go. We don't want to put kilogram at the top. We would be building it incorrectly. So why did I use this conversion? We can tie in the patient's weight, 136 pounds. Now, where does that need to go? In order to cancel out pounds, which was up here at the top, I need to put that 136 pounds down here at the bottom. This understood 1 is that 1 patient. Look at what cancels out. We've gotten rid of all of the words that we don't want. And finally, we have built this last part. We have micrograms at the top. We have minutes at the bottom, but we also have that kg at the bottom. So let's multiply all of this junk together. Now, folks, again, remember, these are the challenging ones. These are the challenging ones. Live session 1, 2, 3. Go ahead and watch those when you get a chance. So let's multiply the top, divide by the bottom. I see a bunch of 2.6s coming in right now. Fantastic. And just to recap that real quick. By the way, I am recording this video as well. I'll edit the video, post it on YouTube. Y'all know the drill if you've attended any of my live sessions before. So 1,000 times 120 times 60 times 2.2. Good gosh almighty, look at that number. This is why I tell people don't write it down. Immediately start dividing by your bottom numbers. So divide, I see a 750. I'm going to press divide again because I see a 60. I'm going to press divide again because I see a 136. Press enter, and this is that 2.6 if you round to the nearest tenth. So yes, we get 2.6, and this is micrograms per kilogram per minute. We have built the double slash. These are some challenging problems here. This looks long. This looks crazy. But y'all, I've been teaching for 15 years. I've been a college math instructor for 15 years. You learn this in chemistry, and plus, this is the way that most schools teach it. Some schools do teach a formula approach. I'm not the biggest fan of the formula because it is limited. So, there's one more problem, but actually this one problem has 3 different questions. I'm doing this on purpose. Now remember number 3? Number 3 is a distractor problem. So I'm going to put this up here. Feel free to try all 3 of these. Now these are not long ones, but there's 3 different things. And depending on which one you're finding, you're definitely going to have some distractors. So let me set this timer up. I'll do 3 minutes for this last one. Go ahead and give it a shot. This is a distractor problem. Just because you have numbers in a problem doesn't mean you're going to use all of them. And that's why I have 3 separate questions up here. All right, so GTTs per minute. Now, this is our goal. So GTTs per minute. And I mean, we're not building a double slash anymore, but technically we still want to build GTTs at the top and minutes at the bottom. So to start off, we definitely want GTTs at the top. And the only thing talking about GTTs or drops is the 20 drops, 20 GTTs per ml. And that is this one right here. That's the only thing that mentions drops. Now, here's where some of the distractors are coming in. We need to make sure that we get rid of the word milliliters. So we must use this 400 milliliters. I'm going to put that at the top so that we can cancel out the milliliters. But y'all, let's bear in mind, what's our goal here? Our goal is to get drops per minute. What we don't want to use in this first example, using that 0.75 grams, that is going to be pointless in this first example. What we want to do here is we want to do that 400 milliliters. That's going to be infused over 90 minutes. So 400 milliliters is going to be infused in 90 minutes. Look at what we have. A very quick dimensional analysis problem. We have GTTs at the top. That's what we want to start off with. And we have built, or we now have minutes at the bottom. Now, with GTTs, there are different rounding rules with certain schools, but pretty much every student I've taught all across the country, every student I've tutored for med dosage, drops is always the nearest whole number. So let's do 20 times 400, and then let's immediately divide by 90. So we're going to round this, and this would go up to 89 drops per minute. Now I'm going to go ahead and cover these other ones as well. So milliliters per hour. Now y'all, watch this one. The 20, believe it or not, the distractor in this problem is going to be the 20 GTTs per ml. That's going to be useless in this problem. I'll explain why in a second. But also the 0.75 grams. That's still going to be useless in this problem. Here is why. We have, our goal is to get milliliters at the top and hours at the bottom. And, you might say, well, why didn't I use the 20 GTTs per ml? Well, look at what we have right here. The 400 milliliters, I'm going to start off my problem with that. And this 400 milliliters, we mentioned this earlier, the 400 milliliters gets infused over the course of 90 minutes. Now, some of y'all may say, well, that's an hour and a half. But again, I'm not skipping any steps here. I'm not skipping any steps. We don't want milliliters per minute. Even though we do have milliliters at the top, we want to get hours at the bottom. So I'm going to finish off with a conversion. There are 60 minutes. I'm putting that at the top. And there's 60 minutes in 1 hour. Cancel out our minutes. And now we have built the correct word in our dimensional analysis. Had we used the milliliters with this 20 GTTs, we would be stuck. Look, suppose you did try to use this right here. Let me get rid of that for a second. Suppose you did try to use this. And let me just enter this down, make a little bit of room. The reason why you would get stuck is because if we wrote 1 ml over 20 GTTs, you may say, well, I'm off to the right start. And, technically you are. You do have the word milliliters at the top. So that is good. But the only problem is nothing else is going to help. You are stuck. There is nothing in this problem that's going to let us get rid of GTTs. You are stuck. And that's another way to help you identify distractors. When you get stuck, if you can't cancel out a word, then more than likely that's going to be a distractor. So just another reason why. Now, if we multiply and divide here, 400 times 60, and then we immediately divide by 90. Let's round this. We'll round this to the nearest whole number. Some schools will tell you to round milliliters per hour to the nearest tenth. And I've seen some schools where they tell you to round milliliters per hour to the nearest whole number. That depends. That changes from school to school. But for now, I'm just going to round to the nearest whole number. So that is another example of a distractor problem. Now, finally, we are going to use this 0.75 grams that was a distractor for both A and B. Because look at what our goal is for this one. Our goal is to get milligrams per minute. Milligrams per minute. So I want to start off with milligrams at the top of my first fraction. Well, we don't have milligrams anywhere up here, but we can do a conversion to tie in our grams. So 1,000 milligrams over 1 gram. Now, the reason I'm using this conversion, I have not used that conversion tonight yet, I don't think, because we haven't had to convert milligrams to grams. We did micrograms and milligrams earlier, but the reason I'm using this conversion is because we can tie in the 0.75, and that is grams. And what are we going to put this over? You might say, oh, we're going to put it over 400 milliliters. Well, the 400 milliliters is now going to be the distractor in this problem. Y'all, we want milligrams per minute. Well, look at what we have here. Of course, the grams cancel out, but this 0.75 grams, sure, yes, it is in 400 milliliters of solution. I don't care. What we also know, this 0.75 grams that is in this solution is going to infuse over 90 minutes. So this 0.75 grams is going to infuse over the course of 90 minutes. We are ready to multiply and divide. So 1,000 times 0.75. And some of y'all probably knew that 0.75 grams was 750 milligrams. That's okay. But I'm not doing any shortcuts here. Immediately divide by 90. And therefore, this patient is going to be getting 8.3 milligrams per minute. So I did see some chat messages coming in. So that's it for the session. And again, I apologize 100 times over about Facebook Live. I hate that we lost some people, but it is what it is. If you have any questions, tag me in a post on the Facebook group. I'm going to save these notes. I'm going to send those over or add those to the group. Thank you all so much for tuning in. I hope you all have a great weekend, and I will see y'all later. Good night.